there are two type of models that you have. Model, and there is another model called TCP IP model. Make sense? So this OSI model and TCP IP model have been the most famous models over there. But why do we actually need these models? Now, whenever the internet came up, okay, the internet was not that big. And what used to happen is companies back then tried to implement their protocol. So no matter what kind of service you use, if you are connected in a network like this, let's say that's your home router, and then that's your home switch, and there are a couple of PCs that are communicated or that are connected with this particular network. And then you have your ISP like AT&T providing you the connection, and then that particular connection is connected with the internet. Cool. So you want to reach out to google.com that is situated somewhere into the cloud, and then you send a request, and that goes on to the google.com, and then you receive it back. Correct? This is how the communication works. But upon each and every communication, upon each and every click that you do on your web browser, there is something called encapsulation and decapsulation.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So you need to understand this thing pretty much. Okay, this is one of the most important things in your networking career that you need to be very clear with. Cool. So pay your attention over here while we are talking about encapsulation and decapsulation. But before that, you need to understand why even these models do exist. So it's just like the same thing that whenever the communication used to happen, there are different type of protocols that have been built. If you want to email someone, then there would be a protocol that is developed as SMTP, Simple Mail Transfer Protocol. If you want to browse web, you will use something called HTTP. Okay, if you want to send some files, you will use FTP. If you want to, let's say, like fetch out some information of IP addresses or so, you will use ARP. If you want to download anything, you will use POP. So for each and every activity that you want to do on the internet, there is a dedicated protocol that has been developed. But back then, when internet came up, there were very limited vendors that used to manufacture PCs and that used to manufacture devices that could actually be connected onto the network. Okay, and vendors do existed majorly. You had IBM. Okay, and let's say there was Dell as well. Okay, and HP as well. These were kind of the vendors, and Apple as well. Okay, these were kind of the vendors that were there. What used to happen is whenever you connect a specific network, let's say you have a router or you have a switch, and that switch needs to be connected with PCA, PCB, PCC, and D. Now, if this entire network is consuming devices that are made up of IBM, then you would say that it will work. But if you are connecting something with a switch that has different set of devices, let's say you have a device of Apple, you have a device of Dell, you have devices of HP, and you have device of IBM, this thing will not work. I'm talking about the days of 1970s and 1980s when ARPANET and things like internet started to get famous. Okay, and the internet was rapidly growing. So back then, the communication like this was not possible. Why so? Because each and every vendor kind of developed their own set of protocols. So IBM had its own SMTP, okay, and then Dell had its own SMTP or HTTP or even ARP or anything. And each and every vendor had their own type of protocols. So whenever, let's say, the communication needs to be done from Apple to IBM, and it's kind of a communication which is FTP. So you're sending a file from Apple PC to an IBM PC. You will be using, of course, protocol like FTP, but that FTP of Apple didn't match with the FTP of IBM. And the easiest example that people do use is if there is a person that talks Spanish, and there is another person, girl probably, that talks French. correct? And I would say the Spanish person kind of talks with the French girl, and he wants to like appreciate the beauty of this French girl. So even though he tries to say anything, the girl wouldn't understand anything because the language that the French girl would understand is not Spanish. So the communication, they both are using languages in order to be able to communicate with each other, but the languages that they are using are not standardized language. Okay, and how they could improvise the communication or how they could make the communication successful between them, right? There would be a breakup within 5 minutes, I would say. So if they would have used English, okay, or rather the Spanish guy would have used English in order to propose or appreciate the beauty of that French girl, then they would have landed up on top of the Eiffel Tower, I would say, and having a dinner. But without them being able to communicate with each other, yeah, without them being able to communicate with each other, they will just stay downstairs at the Eiffel Tower and go to their homes or hotels. And that's why this was kind of the same issue that you would find over here as well. That devices manufactured from the Spanish developer would not be able to communicate with the devices that are manufactured by a French developer. And that's why the organization, which is IETF, kind of proposed that there should be a standardized protocol or standardized model with each one should kind of followed. Okay. So if I give you a scenario that how things kind of started to grow back then, you can say that usually there were devices that had TCP model with it. Okay. And there was a model that was created by IBM, which we called it as DECnet. Cool. So the DECnet model then used to communicate with TCP, and then there came the others as well. So in 1980s, if we just talk about 1980s or 70s, there was just DECnet. And then in 1980s or 90s, then you had computers that followed DECnet as well. You had computers that followed TCP as well. Okay, but if we talk about 2000s, then you had computers that followed DECnet. You had computers that followed OSI. You had computer that follows TCP, and you had computers that followed others as well. And this is what kind of started getting popular. So that's why the need of something that is being standardized was there. Okay, so that the protocols, no matter what the protocols were, SMTP, FTP, okay, TCP, or whatever, these particular protocols needs to be standardized. Okay, DECnet doesn't stands for anything, but DECnet is basically a model that IBM developed. Okay, so and OSI was developed by some of the organization we'll talk about. The organization stands for ISO, International Organization for Standardization. Okay, and the TCP kind of got developed by Department of Defense, which is kind of a private development, but then that was the most logical model that was being used in most of the networks. So you can say that the two models that were famous and that were made standards were OSI at first, which was developed by ISO, International Organization for Standardization, and there was TCP IP model that was developed by Department of Defense, US Army. Okay, and this OSI model is till now called as the most famous reference model that you can have. And then TCP/IP is called as the most logical model that we use. So this is in use, okay, on devices. And this is I would say this is what best for understanding. So we will understand how communication works, okay? And what we are going to talk about with these particular things is encapsulation and decapsulation. Make sense? So as you know that there are we follow something called layered approach. Okay, we'll talk about how this layered approach goes, but each of this particular model has several layers in it, correct? And the layers go like application, presentation, then you have session layer, then you have transport layer, then you have network layer, then you have data link layer, and then you have physical layer. Cool. So we call this as layer number 1, 2, 3, 4, 5, 6, 7. These are the 7 layers that you have, and you can, I would say, remember these by saying, please do not throw sausage and pizza away. Okay. In most of the books that you would see the same thing over here, that you can use, please do not throw sausage and pizza away. Or in Hindi, that's our language, we say, please do not throw Shahi Paneer away. Cool, that's how we remember it. So there are multiple ways that you can remember these 7 layers, but each and every time you kind of click on any information that you browse on the internet, be it Kylie Jenner pictures or be it Bradley Cooper pictures for girls, yeah, you do follow. OSI model kind of helps you to get those pictures on the boards. So we call encapsulation to something when the communication goes from PC to the destination. The information gets collected with the respective of top-down approach, which means the information starts getting collected from application down to presentation, transport, network, data link, and session, like this. And then the information travels, and then the decapsulation happens like this. And encapsulation is top down approach and decapsulation is down up approach. Makes sense? So how does this particular communication works? Let's talk about what kind of information is collected at each and every layers. Let's check out. Yeah, so let's see how this particular communication works, and what kind of data is collected at each and every layer that you have over here. So whenever we are still discussing that how communication is going to happen. Let's say that you are connected to a router and a switch and a couple of PCs over here, right? And this particular PC is going to send some information on ISP end, and then there is google.com, and you are trying to kind of grab some information on from Google. So you are sending a request, okay, and then for this particular request to leave your computer needs to collect some information, and it will collect information for each and every layer that is mentioned over here. So for application layer, it will kind of try to see that what are the resources that are available on your computer that can be used in order to view the data. So we call the top 3 layers as software layers. Okay, then we call the transport layer as heart of OSI, and we call the network, data link, and physical layer as, I would say, hardware layers. You get that? So at software layers, it collects information about all the softwares or whatever the application that you're going to use. Okay, so at application layer, it kind of sees that at application layer, it's gonna check that what all resources do you have in order to be able to view the data on your computer. For example, web browser. Okay, let's assume that you go in your college days or in days like that, like where you need to go to a lunch or dinner, and then at that particular facility where lunch or dinner is being served, there is a servant who is kind of serving the food onto the plates. So you just go in front of that particular person or the servant, and you just say, "Give me food." He's not gonna open up your mouth and pour a couple of, like, I would say, food or food directly into your mouth. Like, open that up. He pours out some sort of like chapati as Indian food, and some sabzi, or there's some dish that has been made, and he just opens up your mouth and fills you up. That's not gonna how it go, right? He will ask you to get a plate, and then on that particular plate he's going to serve you the food. So we can assume the plate as kind of an I would say interface, and we can say that the food is our data. So you can say that the food is being served onto the plate, meaning that if we consider that the information that Google is going to provide us, let's consider that as our food. And where can we access that particular food? In something called web browser. So if you do not have a web browser, you will not be able to, or an application at least, you will not be able to see the information that Google can provide you. So that's the detail that it checks at the application layer. That does your PC has any information, or does your PC has any interface on which the data can be served? Okay, and that's exactly the information that gets collected at the application layer. So you can say that applications or web browsers can one of the information that can be created, and it says whether it supports HTTP or whether it supports DNS or whether it supports DHCP. These are kind of the application layer protocols. Okay, that sits over there. As we talked about layered approach, the layered approach means that each and every protocol that is available out there in the world do sits or do follow some of the layers that it has. Like HTTP is an application layer protocol, IP is a network layer protocol, TCP is a transport layer protocol. Just like that, each layer that each protocol that exists today does sit or does fits into one of its layers. Make sense? So at application layer, it will collect the information that it needs and then it will come down to presentation layer. Now at presentation layer, it's gonna do the work of compression and decompression. What does this compression and decompression means? Whenever the data is going to go from here to there, you are going to get a reply. And this particular reply will contain some of the data. That data might be into the form of text. The data might be into the form of MPEG-4. For a video, that data might be a JPG image. That data might be MP4 video. That data might be MP3. That it can be an audio. So each and every that you see, each and every data that you see does have some data format. And in what data format the data should be displayed or sent or received, that task is called as compression and decompression, and that gets done at the presentation layer. Make sense? So that's what the information is that physical sorry presentation layer kind of covers. Cool. And then it goes down to session layer. So at session layer, let me give you an example over here. You might have seen a web browser, and so when you're accessing a web browser, let's say that there are four different tabs that you have opened. Okay, the first tab is facebook.com, the second tab is yahoo.com, the third tab is google.com, and then there is a fourth tab, let's say youtube.com. Okay, and most of you might have an incognito window as well. So these are the four different tabs that you have: Facebook, Yahoo, Google, and YouTube. And let's say that the PC that this particular browser is using has an IP address of 192.168.1.5. Cool. Now, as this particular PC, which is having 1.5 address, is using different tabs in order to reach out to different servers. So, can we say that Facebook is connected at 8.8.8.10, let's say? Just for example, I know it's a global DNS address, and Yahoo is connected as 10.10.10.10, and Google is available at 12.12.12.12, and YouTube is available at 14.14.14.14. These are different addresses of the servers that they can be reachable. So can we say for first tab, the source is going to be 1.5 and destination is going to be 8.10. Cool. Then for second communication, the source is going to be 1.5 and destination is going to be 10.10. And for third, the source is going to be 1.5. The destination is going to be 12.12. And for fourth tab, the source is going to be 1.5, but the destination again changes to 14.14. Do you agree all this information? Now, this is when the data is going from our end to different servers. But whenever these different servers are going to send you the data back, what can we say that the source will now be different for each and every request or each and every reply, but the destination will just be same. Okay, the destination is just going to be 192.168.1.5. Okay, and the source is going to be different whenever all these servers kind of replies you back. So does it ever occur in your web browser that these tabs kind of opened their information into some different tab, like Facebook's data opened into Google's tab and YouTube's data opened into Yahoo tab. It never happens, right? Because the session layer kind of keeps different application data separate from each other by using port numbers, and it assigns different port numbers to each and every tab and each and every application that is open. And it keeps different application data separate from each other. Makes sense? It doesn't let that particular thing get involved with the other tab. Also, you might have seen payment gateway pages where the page itself says that the page will automatically be terminated in 180 seconds whenever you go forward and enter your Visa password or so. That kind of pages also are controlled by a session layer. So this is what session layer is responsible to. Okay, whenever we talk about its responsibility, the session layer keeps and maintains different application data separate from each other. Okay, do you understand this? I hope the example helps you. Yeah, all right. So I'll just write it in a clean manner because when we talk about OSI now, we said we have application layer, then we had presentation layer, then we had session layer, then we had transport layer, and then we have network layer, and you have data link layer and physical layer. These are the 7 layers that you have. Correct. And we talked about the first 3 layers are called as software layers. The transport layer is going to be heart of OSI, and the next layers are going to be hardware. Makes sense? The application collects information about the resources if that's available. Then the presentation collects the information. The presentation collects information about how the data should be displayed, and the session layer just gives different application data separate from each other. Now there is another thing called PDU, and this PDU stands for protocol data unit. This is kind of an extension and a field where this collected information is stored, and the field that it uses to store this software information is called as data. So the format of that particular information that is collected at top or the 3 layers, that is application, presentation, and session, is just data over there. Cool. Whenever it comes down to transport layer, the data gets added up and gets converted into a field called segment. And what this segment contains, or what this transport layer does, transport layer is one of the most important layers that you have in OSI model. Okay. And this particular transport layer just does the identification of whether TCP needs to be used or whether UDP needs to be used.